All right, in this video, we're going to be solving rational equations. So we're just going to start off with some examples, and I'm going to start with an overly simple example so you guys can kind of see how it works. So if I said I had 1/7 plus x sevenths, and that my answer was 5/7, you'd say, oh, since the denominators are all the same, then I know that this plus this has to equal 5. And so you could say, okay, that must be 4/7. 1/7, 4/7 equals 5/7. And so in your head, you really said 1 plus x equals 5, and so x equals 4. And that's the basis for how we're going to do all these problems. So obviously they're not going to be that simple because we are in an upper level high school class, but we're going to use that idea. So the idea is if you have a common denominator for all of the fractions in the equation, then you can kind of ditch the denominator, you can just ignore it and solve the equation. All right, so here is our next example. We're going to do 1 plus 1 over r minus 1 equals 4 over r minus 1. So if we're doing this problem, we want to make sure that we have fractions for each of the terms of the problem, which means that we're going to go back to that first term and we're going to make it over 1, right? So we have that fraction. And then we need to have a common denominator for all of those terms. And so the common denominator would just be 1 multiplied by r minus 1. So the 1 in this denominator and the 1 in these denominators are different. This one is kind of like a coefficient, and then these have to be considered groups. Now, if you don't want to put the 1 in front, you don't have to, because we know that this 1 as a coefficient isn't really going to make a difference. So what I'm going to go ahead and do is I'm going to take that first fraction and I'm going to multiply by r minus 1 over r minus 1. So I have r minus 1 over r minus 1 plus 1 over r minus 1 equals 4 over r minus 1. And at this point, we're kind of at the stage where we were right here, where we said, okay, 1/7 plus something over 7 equals 5, it must be 4. So here we can say, all right, I have the same denominator for all of these, so I can get rid of the denominator. I can just write a simple equation for that. R minus 1 plus 1 equals 4, and the ones cancel, and so r equals 4. Now with these, we do have one extra step. The extra step is that we have to go back and we have to check and see what the excluded value is. We have to make sure that our answer is not an excluded number. So if I look at this equation, the excluded value is 1. R cannot equal 1 in that equation. So what I'm going to do is I'm going to compare that with my final answer down here, and my final answer is 4. And that's not 1, and so my answer is okay. If I had done the problem and my answer had been 1, then I would have said, okay, that answer doesn't work. There's no solution to the problem that's possible. Okay, so we always have to check it just because every so often there could be a problem where you solve it and it ends up being that number. Okay, here's another example. We have 4n plus 24 over n plus n minus 4 over 2n equals 1 over 2. So if we look here, we have an n and a 2n and a 2. That means that my common denominator definitely needs to have a coefficient of 2 in it, and it definitely needs to have an n in it. So the first fraction is going to multiply by 2, just kidding. 2 on the top and the bottom so that it has that common denominator of 2n. This one already had the common denominator, and then this one needs to multiply by n on the top and the bottom. So I have 8n plus 48 plus n minus 4 over 2n equals n over 2n. And so at this point, I have a common denominator all the way across, and so I can get rid of it. So I've got 8n plus 48 plus n minus 4 equals n. So that's 9n plus 44 equals n. I'll go ahead and subtract the 9n over. So 1 minus 9 is negative 8. And then I'll go ahead and divide the negative 8 over to the other side. And I see that that fraction can be reduced. I can divide 4 on the top and the bottom. And so n equals negative 11 over 2. You can leave the negative on the bottom. You can move it to the front. You could move it to the top. It doesn't matter. Okay, let's go ahead and try another example. I didn't label the last one. This is example 4. Okay, so here we have n minus 6 over n plus 2n plus 4 over n plus 6 equals 4. So again, we have a rational equation and one of the terms is not written as a fraction. So I'm going to go ahead and just put it over 1 so that we have a denominator there. And then I need to go ahead and figure out what my common denominator would be. I know that I need the n plus 6 as a group, and all three of them. And then I need a plain n and a 1. You could put one n in the front if you want, or you could just put n. However you write it is fine. So for the first fraction, we have the n, but we need the n plus 6. Plus 6 on the top, n plus 6 on the bottom. The second fraction has the n plus 6, so it needs an n on the top and an n on the bottom. The third fraction only has a 1, it needs all of it. It needs an n and an n plus 6, an n and an n plus 6. Okay, so I have n plus 6 and minus 6 over n times n plus 6. I'll go ahead and multiply this. 2n squared plus 4n and 4n squared plus 24n. So you can see this example is going to be a little bit more difficult than the one we just did. But again, I have my common denominator, and so I can go ahead and get rid of it. So I'm going to go ahead and just write this part right here. So anytime I have the parenthesis next to another parenthesis, I do have to FOIL that. So I have n squared minus 6n plus 6n minus 36. Okay. So what I have now, I have an n squared and a 2n squared. So I've got 3n squared. These cancel each other out, and then I've got a 4n, negative 36. Okay, so I can recognize that this has an n squared in it, it has an n in it, it has a number. So this is a quadratic, which means I need to make it equal 0 and I need to factor it to solve it. So I'm going to go ahead and move everything to the side where the n squared is bigger. So 4 is bigger than 3. So I'm going to go ahead and minus that over. So that's just n squared. I'm going to go ahead and minus the 4n. So that's 20n. And then I'll go ahead and add the 36. And so everything cancels out, which means on the left side all I have is 0. So I am looking for two things that multiply to be a positive 20, sorry, multiply to be a positive 36, but add to be a positive 20. And those numbers are 18 and 2. And so n equals negative 18, n equals negative 2. And I'm going to go back and look for my excluded values. I have two of them. So here my excluded value n cannot equal 0. There n cannot equal negative 6. And if I compare those with my answers, I can't have 0, I can't have negative 6, and that's totally fine because my answers were negative 2 and negative 18. So I'm not worried about it at all. All right, and we're going to go ahead and do one last example. So we have m minus 1 over 3m squared minus m minus 1 over 6m squared minus 2m equals m squared minus m minus 12 over 12m squared minus 4m. So all these denominators look pretty different right now, but I feel like they kind of look similar. Like they're definitely not the same, but they look very similar to me. So what I'm going to do is I'm going to factor each one so I can determine what's the same about them and what's different about them. So for this one, I see a GCF of m, and that would leave me with a 3m minus 1. Here I see a GCF of 2m, and that would leave me with a 3m minus 1. So there we have something in common. And here I have a GCF of 4m, and that would leave me with 3m minus 1. So for my common denominator, I definitely need that 3m minus 1. All three of the fractions have it. All three of the fractions also have just a point m in the front. And then these two have a coefficient of 2 and 4, and the first one doesn't have a coefficient at all. So between 2 and 4, the GCF, not the GCF, but the number in common would be a 4. Okay, so the first fraction needs a 4 on top and a 4 on bottom. The second fraction needs a 2 on top and a 2 on bottom. The third fraction had all of it, it didn't need anything. So I have 4m minus 4 minus 2 equals m squared minus m minus 12. And at this point, I have that common denominator that I wanted, so I can get rid of it. So I have 4m minus 4 minus 2 equals m squared minus m minus 12. And again, I can see that this is going to be a quadratic, and that's because I have an m squared in the problem. I also have m's, so I need to make this problem equal 0 and use factoring to solve it. And the m squared is on the right side, so I'm going to move everything over there. So I can go ahead and combine like terms here first, though. 4m minus 6. Okay, now I'm going to go ahead and move everything over. So I've got m squared minus 5m minus 6. So I'm looking for two numbers that multiply to negative 6 but add to negative 5. And that'd be negative 6 and 1. So my two answers are positive 6 and negative 1. If I go back up to the original problem and I look at these denominators, I can see that right here m cannot equal 0. And here m cannot equal positive 1/3. And neither one of those is the answer, and so that means I'm good. I don't have to worry about either one of those answers being excluded.